welcome back to the channel. I've got a good update for everyone. Please help me out with this. Not my wiring and or anything like that, but I've only got one Arduino. I've only got one little bitty test motor. This is a 3-phase permanent magnet motor wired in star. This is also a 3-phase permanent magnet motor wired in star. There's the rotor for it. Here is the code that I have programmed into my Arduino here. This is an Arduino Uno R3. I've got it hooked up to this little power supply here. I did have it hooked up to the computer, but I wanted to show you guys that this circuit, the 3-phase H bridge here, that is hooked up to this motor, is completely isolated. So let me show you. I've just about got it completed. The coating's right. Everything works. I've got to do a little bit of changes to the coating. I've also got to input a potentiometer. I'm not gonna put any Hall sensors on here, but yeah, see this? That is a 3-phase permanent magnet motor wired in star. I will be sharing all of this, every bit of the wiring. It looks complicated, but I promise you it is not nearly as complicated as it looks. I'm using 6 N-channel MOSFETs, which is the reason why I've got all these resistors on here. These are 1K resistors. I've got this MOSFET down here heating up a little bit, and the rest of them are not even getting warm. So I've got a little bit of a wiring problem here. I just put this together. It really didn't take me but a couple of hours. Here's the other one right here. The last one that I built, those are IRF 630s there, N channels, and these are CEP 50N06s, which I got the data sheet right here. You can see their limit is 60 volts. The gate source, plus or minus 20 volts, but you can put 50 amps to this thing. Right now I'm of course using, as always, this 2200 milliamps per hour 11.1 volt RC car battery, which is actually what powered this thing before, using well, I can't, anyways, this receiver, this transmitter, and here's part of this 3-phase controller here, which it's just basically the same as this, except this is a prototyping board, Arduino Uno R3. This one was made by Elegoo, but I could, I could unplug this. This is just my data port cable, and I've got it hooked up to the battery here, so that I can run all this code. Program it into there, which it's really not a lot. It's basically the same code over and over, but and if you'll notice, I do not have I've got a set speed on here, pin 13 on, which you'll see that this little LED right here goes to pin 13, so I could put LED from 13 to ground, and it would come on with that one. So it's really not anything special. If you guys would like to help me out, you can do that. PayPal.me/Thomas Bowie. It's just my name. I'm going to work out the kinks in this, and then we're going to be wiring it up to that. 3-phase motor. 3-phase permanent magnet motor there. The washing machine motor that everyone is trying to find a controller for. Like I said, this will be I will be open sourcing this with everyone. We'll be sharing this with everyone for free. As always, there's only a couple of videos that I will be charging money for, and it may not even charge money for those. That is, if you know, if I can start getting some funding and stuff. Oh, hey, look, there's some sandstone with some gold in it. Ha ha ha. Yes, I know my fingers are dirty. Hey, I've got to find my sources somehow, right? But here's a little short update video. And this is only 6 wires plugged into this Arduino here. That is the gates, the low and high, for each phase of this 3-phase H bridge. Let me show this a little bit closer to you, because most people don't explain this. You've got your gate, drain, and source on your MOSFET here. And if you'll notice, on the negative side, which the top 3 are all negative, the bottom 3 are all positive. Okay? All 3 of the drains are hooked together, and all 3 of the sources are hooked together, just like a regular 3-phase H bridge. Okay, so gate, drain, source. Now the drain for the negative is hooked up to the source on the positive. So the middle here, the drain, is hooked up to the source, which is on the bottom one. And you'll notice that is your output that goes to your motor. And that is on each of the 3 phases. Now I could continue the circuit and build 3 more and have a 6-phase motor controller. There really isn't a limit to what you do with this. And I have the gates hooked up to the Arduino. This Arduino is running the gates by telling it to turn this one on and that one off, and this one off and that one on, and this one off and that one off, all at the same time. So it is telling all 3 of these what to do at every single step of the rotation of the 3-phase permanent magnet motor. It's, like I said, I know it sounds a lot more difficult than it is, but it really isn't that difficult. See the output to the motor. Let's see here. The output to the motor here is hooked up to the top one on the drain and the bottom one on the source. And that's on your MOSFET. Okay, now like I said, I've got these resistors hooked up, and that's just to protect this Arduino. I've only got one. They're about 15 bucks. And of course you guys know how poor I am, so I can't I can't really afford to just burn everything up, you know, without cause. So I'm trying to take as many precautions as possible. These are 1K resistors, every one of them, and I've got 2 left. I don't have a smoothing capacitor on here. This is just direct current, that's not what's going to initially be powering the large motor. I'm going to use an H bridge coming off of a power inverter. So I'm going to go from a DC car battery to a stable sine wave, and then I'm going to use the top portion of the sine wave with a 4-wave bridge rectifier with a smoothing capacitor on it, and that is going to give me the input right here for my 3-phase H bridge right here. Now, like I said, these are little bitty MOSFETs. It's not what I'm going to be using. You'll see, this is what I pulled out of a television. You'll notice they are a lot larger, and I will be putting heat sinks on them, just like I've got this one right here. This is just one right here, but you'll have to have 6. So here's a nice little short update to go with the other video that I'm uploading. And if you guys can afford to help out, then go ahead and help out. If not, then you can help out in other ways. Give me a like. If you're not getting notifications of my videos, make sure that you're subscribed to my channel. All 3 of these are hooked up the same way. Here's the gates coming out for this one. Here's the gates coming out for these 2. And here's the gates coming out for these 2. It goes gate, drain, and source. Like I said, the drain, which is hooked up to the negative. This is the negative wire over here. I'm sorry, the negative is hooked up to the source. Wow. It's late, it really is. It's, oh my goodness, it's time for me to go to bed. We got doctor's appointments today. I was going to say tomorrow, but it's today. But the negative is hooked up to the source, and the positive is hooked up on the bottom to the drain. Gate, drain, source. Source is negative on the bottom, the drain is positive. Let me see if I can show you on this one. The orange wire is the output, the black wire is the negative, and the red wire is the positive. Now on all of them, the gate, like I said, which is the one on the left, on every MOSFET here, the gate is going to the Arduino. So I've got it over here. It goes from it'd be the low and the high, and then the low, and then the high, and then the low, and the high. So it's really it's not as complicated as it looks, and you do really need these resistors on here. If I had 3 N-channel MOSFETs and 3 P-channel MOSFETs for my H-bridge like it's supposed to be, which you can see here. It's been raining, so this is the diagram for the electronic speed controller that I built before. Here is the diagram for this one. See, all of these are all hooked up the same. They're all N-channel MOSFETs. but you really need 3 N channel and 3. You need 3 NPNs and 3 PNPs for this project, and that's so you don't have to have as many resistors, and you're not really you're not risking your microchip here, microcontroller, which is a it's an ATA. I can't see it. It's 328. It's at Mega 3. Yeah, ATA. Or, I'm sorry, ATM EGA at Mega 328 P-PU. Oh, there we go. We can see it now. Yeah, at Mega. So, anyways, here it is. Got a little bit of modifications still got to be done to the circuit, and I didn't use 10K resistors on mine. I used 1K resistors. I didn't use the RF Z44Ns. I used these little 50N06s, CEB 50N06s. They're N-channel MOSFETs. Let's see if I can get that to zoom in correctly. There we go. Yay! But always print out your data sheet, you know, so you'll know where the gate, the drain, and the source is, you know, for when you go off of your blueprint, your diagram. Always, you know, after you hook it up, always hook it up here first. Make sure that none of these burn out or blow up before you've got it wired up to your sensitive, you know, microcontroller. Now, of course, it'll tear up these resistors before I tear up my board, and also because I'm using 6 NPN, or 6 N channels MOSFETs. These resistors are turning my gates off and making sure that the voltage and current is drained out of one before the other one turns on. So that's the reason why I wired a 1K resistor to every gate on every MOSFET. This gate and that gate, both to the positive for the battery here, and that's the reason why I did that, so that it'll drain it out of here and it won't let it go back into there. I don't want to tear my microcontroller up, my Arduino. If I do that, then I'm screwed, because I don't have another one. So, here it is. I've got to get to bed. I will scroll through what coding I have on here so far. I just titled it 3-phase BLDC control. That way I can find it real easily in my system. You can title yours whatever you want, you know, on your system. But let's go see. This initializes the pins. This tells pin mode tells what the pins do. They're all outputs. Setup, you know, void setup. What's it doing? Void loop. It'll do this, and then it'll do it over and over. Then you've got your digital write, which tells each pin what to do at each point. So P11, which if you'll look, P11 goes to number 8 on your Arduino. P10 will go to number 5 on your Arduino, and that just tells Arduino which one. See down at the bottom, so you've got on your Arduino there are numbers. It's 8, 9, and 10, 5, 6, and 7. So this is one side of your MOSFET. This is the other side of your MOSFET. Pin 13 is telling it when it's on, and initialize DB7, which is going to tell you basically. Let's see. Do I even have that hooked up? Yeah. Okay. Yeah, it is. But anyways, I'll go ahead and show you the code here. Let's see, scroll through there. I may be able to edit the comments section and put, copy and paste this into the comment section. I'll see if I can do that. Yeah, because it's going to be so hard. I'll just try and do that. This is going to be hard for people to sit and type all this out. I'm gonna have people do that. I'll make sure I get it in the comment section, or actually I'll put it in the description. That way people don't have to fight and look through the comment section through all the nasty comments that I'll probably, oh, you're a horrible guy, But anyways, don't forget to hit the like button on the way out, and to get notified, make sure you hit that subscribe button. It is time for me to go to bed. I am wore out. So I will see you guys later. Hope you enjoyed this really boring video. And live life loving, man. The day you give up is the day you lose everything. And I try and stress that as much as possible. But we're going to get this out to the world. We're going to show everybody. Alright, love you guys. Have a good night.